Hello everyone and welcome back. Today we are going to talk about dbt, one of the most important tools in modern data engineering and analytics engineering. I have been working with dbt for several years across multiple real-world projects using both dbt core and dbt cloud in production environments. I'm also a dbt certified developer, a certification that requires a deep understanding of dbt architecture, workflows, and advanced features. In this video, I will explain dbt from practical perspective, not just what it is, but why it exists, the problems it solves, and why so many organizations have adopted dbt as part of their data platform. We will start by looking at how data transformations were typically managed before dbt, like the challenges teams faced, and how dbt introduced a more structured, scalable, and reliable approach. Then we'll explore the key advantages of dbt and understand why it has become a standard tool for analytics engineering. Whether you are hearing about dbt for the first time or you are preparing to use it in professional environment, this video will give you a solid foundation and help you understand what is dbt all about. Let's get started. Let's understand what is dbt and what is the problem that dbt solves. We'll get into dbt and understand how dbt helps us solve our data problems in a moment, but here's the thing. To truly understand why dbt exists, we first need to feel the pain it solves, okay? So let me walk you through a real-world scenario, the kind of things that happens in almost every company working with data. Here is how data works in most organizations. As a data engineers, data analysts, analytics engineers, we work with data every single day. And in the real world, data doesn't come from just one place. It comes from everywhere. You have got SQL databases, MySQL, PostgreSQL servers. You have got APIs. You've got Internet of Things devices and sensors. You've got ERP systems. All of these are generating data every single day. And all that data gets ingested into our data warehouse. Here I'm using Google BigQuery as an example, but it could be anything. Snowflake, Databricks, whatever the data warehouse that you are using. When that data lands, it goes into what we call the raw data set, because it's exactly as it came from the source, untouched. And this whole step, pulling the data from the source and dropping it into the warehouse, that's the extract and load, the E and L. Honestly, this part usually works fine. We can configure this very easily. Most of the databases, especially with the cloud right now, for example, with Google Cloud, we can configure that and build the connection right away, and the data start flowing in the first 5 minutes. So it's very easy to build the connection with different systems right now. It's even getting easier and easier because the cloud is becoming very popular and most of the systems support this kind of thing. So you don't really need to worry about that. Even if we have a new system, it's very easy to write a Python script, schedule Docker container, or maybe kind of configure Kafka or PubSub for streaming. So all of this, we have systems here. As a data engineer, you're supposed to be aware of it, but it's not really a problem here. It's very easy to do that, especially with the cloud, right? There are managed services where you barely write any code. So you just configure them and the data flows in easily. But here is where it gets interesting. That raw data that we have here, it's not ready for a dashboard. It's messy, right? We can't really use a dashboard to show our data because we have nulls, we have unused columns that coming from the source. We don't really want to show them values that need cleaning. Maybe we need to enrich the data as well by joining with different tables. This is very common. So before we can visualize anything, we need to transform it. That means we need to move data from this format, from the raw data set, to a staging layer, and then into marts. That means the data that reach this data set is very clean and ready for visualization. That's our main goal, the whole journey of our data. That's what we want. Now we might need to create an external data here. Let's call it intermediate data set. If we want to transform the data even more, can do that easily, as this process should be very flexible for you to transform the data as you need and make the data ready to the dashboard. This is our journey here. Now we understand how we ingested the data, right? We have managed services. It's very easy to get the data into our data warehouse. That's not an issue here. The data is in BigQuery. Now what? Before we continue, if you are working towards becoming a data engineer or analytics engineer, I also run one-on-one coaching program where I help students and professionals build the skills needed for real-world data projects and interviews. If you would like to learn more, you will find the link in the description. All right, back to the topic. Let me show you what data transformation looked like before DBT and why it becomes such a challenge. This is the big question. We are talking about the transformation, okay, but the question is, how are we going to transform the data? You said, okay, we remove nulls, we remove few columns, etc. We write SQL queries to clean the data, but how? You have the data here in BigQuery, and then you created a new data set, kind of a new folder to get the new tables, the clean tables. Let's say if you have a orders table or you have a customers table here, it has the customers data, orders data. You need to transform the data and only add a few columns that requires by the business and create a new table for that, put it in the stage. Maybe we need to join these tables with different tables to enrich the data, etc. We can put them into Mart for a specific department, different folders. When I say dataset, you can consider it as a folder where we can have a different tables based on our business needs here. Let's say if we have a sales department, we can create for them specific folder as a sales. Then we just get the data, the exact data that they need. So we can organize this data. But the thing is this, the question, how are we going to copy the data, move the data, clean the data into different stages, different layers inside Google BigQuery? This is the question. In other words, how are we going to transform the data inside our data warehouse? You might say, well, I can actually write SQL queries inside Google BigQuery. Well, that's perfect, great start. But the data flows every single day. You need to run this SQL query every day. You might say, well, I know Google BigQuery provide a feature where we can schedule our queries. We can write a SQL query, then we can schedule it in our BigQuery or in Databricks or Snowflake, whatever the data warehouse that you are using, and it will run every day. It will create the tables. Everything is perfect. Amazing. That's great news. Now we start thinking about transformation and everything is set up. Schedule queries, recreate the tables and the right folder that we want. And for that, the dashboard is going to be refreshed every day as well. So everything works fine. Okay, now we understand that could work, right? But the issue is this. It's never just one table, right? Because you have many systems, might have tens, hundreds, or even thousands of tables. You have a very big data team working all together to transform the data. Because we have huge amount of data, terabytes of data, and it's very big data. How are we going to resolve this? Is the scheduling queries going to be reliable in this case? Here is what happened when we use scheduled queries or writing scripts to transform the data. I'm going to explain in details what is the problem with this approach. So let's see. First, you write SQL scripts, right? Scheduled queries. Because you have so many different tables, you will need to save these scripts somewhere, right? So it will be scattered across folders. Schedule the queries with no version control. That means these scripts or scheduled queries can't really be tracked, or we can't really track what happened, who changed this query, etc. We can see only who changed it last. The person that changed this query last will be easy to identify, but we will not be really able to identify what changed, what are the changes that have been done for this particular one, what happened last week, etc. So there is no version control. Business logic duplicated in multiple places. Because we are not aware of the scheduled queries that our colleagues created last year. We are not aware of this particular logic. We don't know, maybe already written there, but we come along, a new engineer comes in and couldn't really find that logic, and they tried to write that logic again. So we'll have duplicates here. Or let's assume that there is some changes, and if I come and business asks me to change something in the logic, I would prefer to duplicate the existing scheduled query and update that one. So in case something happens, so I can go back to the previous one, kind of create a new version for the scheduled query. If that makes sense. So there is no automated testing. Let's say I change the logic, so I can't really test what happened with the new logic. I will be able only to test it in the dashboards, which is not we want, right? We don't want our business to test our data. We just want to provide them ready data, accurate. We want them to trust our data. So testing doesn't exist. There is no documentation. We only have SQL queries. We can't really write a documentation. We don't have a system for that with the scheduled queries features. There is no ownership or clean responsibilities. Breaking changes discovered by the dashboards or users. So if we have some breaking changes, if we have some errors, tables change, different names are changed by the source, etc., we can't really see scheduled query is going to fail. Therefore, the dashboard is going to fail as well. So we'll not have data in our dashboard, which will affect our business users. Debugging means who touched this last. We can't really debug what happened. We will be able to see who touched this last, and we can't really identify what is the things that been changed for this particular script or this particular scheduled queries. After all of this, we will get this result. Look, trust is everything in data. Without a trust, all our work is useless. So when numbers change without explanation, people stop believing the data automatically, right? Because one day the dashboard says one thing, the next day something totally different. Eventually the business just stop asking, they stop trusting our data. And the problem is once trust is gone, these dashboards that we invested so much time to build are worthless. So what are we left with? We have fragile pipelines, slow development. Every tiny change takes forever. Not because it's hard, just because everyone terrified of breaking something that can't see actually, because we don't have the visibility to see the effects of our change. Painful onboarding. New engineers will join and immediately ask which table is correct, right? Where the logic, is it safe to change this? And nobody can answer. And finally, the fear of a change. The team stops improving, nobody touches anything, the system just stays broken because we can't really fix it. We are worried maybe if we add extra thing, if we change something, maybe we'll break something. So kind of worried about that. We don't have the freedom to improve. So we kind of live with just a stable enough to survive. And it never gets better, just worse. So basically this is the result of our current solution with scheduled queries. So yeah, the transformation layer is scary. We desperately need a structure here. And that's exactly where our hero shows up. And here it comes to save us from drowning in all these select statements, scheduled queries, DBT, data build tool. Now, before we go further, let me clear up the single biggest misconception about DBT. A lot of beginners think DBT is an ELT or ETL tool that is extract, load, and transforms. It is not. DBT only handles the T, right? The transformation. Not the extract, not the load, just the transformation. And it does that perfectly. So the key idea here, DBT lives inside your data warehouse. Whether you are on BigQuery, Snowflake, Databricks, etc. DBT sits right in there and moves your data around, building, cleaning, organizing data models that you can actually trust and visualize. But it does it with structure, with discipline, and with rules. Okay, now we understand, but how exactly does DBT fix everything we just talked about? Let's break this into two parts. Why DBT exists and what you actually gain from it. The purpose of DBT. The single most important thing, DBT brings software engineering discipline to analytics. Think about it. Before DBT, transformation was treated like scripting, right? Writing scheduled queries, etc. Just throwing queries around. But with DBT, your transformations are treated like real engineering. We use Git, we review changes, we collaborate as a team. It's the exact same discipline software engineers have used for decades. But now it's applied to our data. That means transformation become reliable, testable, and scalable. If the data is wrong, the test fails early before it ever reaches the dashboard. So we catch it early, we fix it, we move on. The business never even sees it. So that means it turns our SQL into production-grade data models. With dbt, a query isn't just a script anymore. It's not just scheduling queries. It becomes a model with dependencies, tests, documentation, and ownership all attached to it. So in dbt, we don't call it a scheduled queries or a script, we call it a model. And in this model, we'll have something called dependencies. We understand what are the dependencies for this particular model. If we want to add test cases, we can add for that test cases. At the end of the day, this model is just a scheduled query. You can consider it as it was before, but not exactly right now. It's structured. We can set up dependencies. We can check the test cases for this particular model. We can add documentation, ownership, etc. Now with this, we will have an advantage. The advantages of dbt. First one, SQL first transformations. If you know SQL, you basically already know dbt. No new programming language to learn. You just learn how to configure your models and set up tests. Few other things, but it's very easy if you know SQL. It runs inside your data warehouse, which means better performance, better security, and less complexity. Also version controlled SQL. Every change tracks who changed what, when, and why. One alone is a game changer. A structured transformations. No more random scripts. You get a clean staging layer, intermediate models, and marks, right? Anyone can follow the flow. Tested and trusted models. Test for nulls, uniqueness, freshness, or write your own custom test. If something breaks, you know before the business does. Documented datasets. Documentation is built right in. So new engineers doesn't have to guess or hunt people down. They just read the documentation. Clear lineage and dependencies. dbt shows you exactly how data flows in beautiful lineage graph. So before you change anything, you can see what it will affect. And it scales with teams and with data. More data, no problem. More engineers, still fine, because everything is structured and documented. So let's bring it all home. We started with chaos, right? SQL scripts everywhere, scheduled queries, no structure, no testing, no documentation, broken dashboards, and the teams afraid or worried to change anything, right? And then we saw how dbt helps solve those problems by bringing structure, testing, documentation, version control, and clear ownership to our transformation layer. If you found this video useful, hit the like button. It really helps the channel and helps more people discover this content. And if your goal is to become a data engineer or analytics engineer, don't forget to check out the one-on-one coaching program. The link is in the description. I would be very happy to help you on your journey. Thank you so much for watching, and I will see you in the next video.